All right, so good evening. I'll wait for the IT guy to get the presentation coming up. So I'm here to talk about something that might be a little bit more basic than some of the subjects we've been talking about tonight, but I believe no less important than all of those. So at Creadditive, we're part of the Groupe Maillet group of companies. So two of our sister companies, Eco Construction and Acoustic SM, are sub-trades for general contractors dealing specifically with fireproofing and sonorization and interior system. We at Creadditive are the digital arms of those companies. So to give you a little bit of context, what we do is we use LiDAR-based equipment to scan spaces and then use this LiDAR data to prefabricate elements. The reason I explain all of this to you is to show you where we come from and why our perspective is a little bit different than some of the other people in the audience. My colleagues and I at Creadditive come from a mechanical engineering background. We aren't architects or land surveyors, so we don't treat data the same way architects and land surveyors treat it. We're focusing on manufacturing and how we can get advantages from these BIM technologies in construction site through building things faster, more efficiently, and looking at how to reduce costs that way. So a lot of the projects that we've done focus on historical restoration, buildings that are under construction or under renovation, the Parliament building, the Ottawa LRT stations, and we range or span everything from the very old to the very new. So that being said, all of this is to address challenges that we see in the construction sector all the time. We hear the same story about the shortage of qualified labor, right? We're all looking to get the best people and to get these people on site working as quickly as possible. And you know, in this day and age, we have to get people right out of school who might not have all of the skill sets required to function in a fully digital world and to build things in the physical world. So in this day of political correctness, I want to apologize right now to all the children in the room who might not appreciate being compared to construction workers. But my whole goal is not to insult, but to have a little bit of fun. So another of the challenges that we see and hear about is that digital literacy in some cases is lacking. People are being used to work with tablets, to work with smartphones on the job sites, but not all of the data is translated into the best format possible for them to work with it. We still rely on paper plans. We rely on 2D drawings to represent 3D objects. And so moving towards full digital literacy is still one of the challenges in the construction sector. And finally, complex projects typically run over budget and behind schedule because the collaborations that we have to do are very complex. If one trade is behind on its work, it might affect several trades downhill and create those extra costs, and the lateness that it engenders. So we're trying to use building information modeling data and prefabrication to overcome some of these challenges. So we're seeing with time the digitization of the toolbox. We're seeing people carrying personal computers around to work sites, using iPads or phones pretty much every day, the same way that tape measures were being used every day on construction sites. We're seeing LiDAR-based scanning equipment being implemented on sites to be able to measure and acquire data as it's being produced. And we're also seeing UAVs being used to survey buildings in ways that humans can't by being able to fly over buildings to produce those data. BIM is also enabling the digitization of business models. So it's not just the data that we talk about, it's not just the models that we produce that is important, but it's the whole digital workflow of a construction business. We're seeing the value chain being changed significantly due to the fact that digitization is occurring. If you're not being digital friendly, in some cases, you can start being excluded from the value chain. So making sure that all the companies in Canada, regardless of their level of digital literacy at present, are included in the value chain, both domestically and abroad, is a very important subject of discussion. And once again, BIM and prefabrication allow us to be competitive with those new business models that are based on the digital world. Now, why do we do the things we do in BIM? Well, it's easy. We're seeing very tangible elements being seen, such as reduction of site labor, reduction of cost, increase in the amount of profit that can be generated from a construction project, acceleration of the completion of building projects, reduction in the conflicts that arise out of building projects. So this whole digitization of the business model is translating into real gains for companies. So how do we go about it? Well, we have to digitize the workflows, directly starting with the architects that design the buildings, to the civil engineers which need to prove the buildings according to the standards, the structural engineers which need to design the exterior envelope and the load-sustaining elements of the structure, the mechanical engineering and plumbing engineers which need to create the duct work, the electricity work, and the plumbing work that make us live comfortable lives inside buildings. And finally, the builders and fabricators who are tasked to take all of this digital data and create something physical out of it. Finally, building owners are seeing value in using the digital data to maintain and future-proof their assets along the value chain. And that's where prefabrication processes using 3D scanning coming to line. So the way projects usually work is that an existing building or an existing structure its geometry is being captured for a renovation or a retrofit operation. This physical data is converted to digital data using scanning techniques. A construction layout is built or merged together with architectural drawings or merged together with engineering drawings inside the digital world. And once the finalized and approved building plans are done, we can go back into the physical fabrication of elements and then the capture of this data once again for validation or documentation purposes. So the famous as-builts that we keep talking about. We'll be talking then about the different types of projects that you can do. This is an example of the House of Commons, in the West Block of Parliament, below the House of Commons in a government meeting room. In this case, for architectural woodworking, a support structure needs to be built to support the wood panels that would go into the roof. So an architect designed a very complex and a very beautiful wood ceiling structure, but with all the curves that were integrated inside the geometry, you can imagine that someone building this using only a tape measure could only take so many points and make curves as accurately as they could using a very tight schedule and a tape measure. So not everything was done as per the drawing perfectly, which is normal and to be expected. The issue is that when you prefabricate wood, you need to essentially cut it to size. So what companies usually do is they cut it a little bit oversized and do the finishing work on site. That creates a lot of dust, creates a lot of on-site work, and in some cases, if your panels, even with the oversize, doesn't fit, you have to reorder panels, which can take 4-6 weeks of work to redo. That's a huge issue, but using laser scanning, it's possible to really digitize the way the support structures are built, and from that to create the CNC cutting instructions that are required for the manufacturing of the wood panels. What happens then is that one week's worth of site labor becomes 1 day's worth of site labor. You don't need to shim, you don't need to cut on site, you don't make noise, and you don't make dust. So in addition to being more friendly towards the tenants, the company can reduce its amount of risk and essentially, or hopefully for the government, reduce a little bit its bid price because the mitigated risk has been dealt with. What that does is also you have a beautiful structure that basically goes up like Lego. You can have all of your panels numbered from 1 to 36, and you essentially ship them sequentially and install them on site as they come in. This isn't necessarily always done for wood. There are ways that we can also do other materials, metal materials, glass materials, or acoustical panels. In the floor above, in the House of Commons, I like to say that the people in government, sitting in government, don't like to hear themselves shout. So when there's an echo, they prefer to keep their voices down. So to mitigate the fact that other people can't hear them or that they don't want to hear themselves shout, Acoustic SM was mandated to build a custom acoustical panel system on the roof in accordance to what was existing. The issue is that all of the beams for the new House of Commons, if you've seen them, are at a 55-degree angle with respect to the ground on one axis and 33 degrees on the other axis. So building a support structure for something that is complex in 3 dimensions sounds fairly easy to people with a mathematical background, but for people who spend their whole lives building things in the real world, getting those measurements are very, very difficult. The other point is that, you know, if you have half a degree of error on your measurements over 1 foot, it's not a big issue. But over the entire length of the House of Commons, you can see that it makes a significant difference if you're only half a degree off. So what you see is that the architectural plans that were made for this didn't line up with reality. Since there were just a little bit of deviations within the allowable scope of work, the structure that was planned using the Revit tools that were used didn't line up with the existing geometry. So we were able to basically correct all of this geometry using the 3D scan of the existing House of Commons, and then produce all the shop drawings necessary to produce all of the panels and all of the framework for the panels. That can also be used for glass. So you probably all recognize this building in Ottawa. So it's the National Art Gallery. All of these triangular windows had to be replaced. And so measuring each and every one of those triangles by hand would have been a very, very time-consuming piece of work. But it is possible to scan all of the framings and the mullions of the glass using 3D scanning. It was then possible to create shop drawings of all the framings and all of the glass panes to increase the certainty of ordering the glass, order the glass faster, and reduce lead times. This creates a situation where we're able to get accurate measurements in even hard to reach or elevated surfaces. In terms of, let's say, the historical setting, digital reconstruction of historical elements, especially broken historical elements, is a very important part. Usually all of this work is done by hand using an artist that is fairly renowned and so doesn't have too many availabilities and charges a little bit more than I do an hour. The process using BIM technology is to actually take the physical object, scan it, digitally restore it. So using the other pedals, the data from the other pedals in this case, we were able to recreate the geometry that was missing and then extract this data to produce a reproduction using, in this case, a digital manufacturing technology such as 3D printing. Once that 3D printing plastic model has been manufactured or fabricated, it's then possible to go back to traditional trades and create a silicone mold that's then used to create a plaster casting, which can then be installed on site. What is very important is that in this case, all of the data that has been extracted from the fracture surface is preserved. So without having to damage or further work the original piece, we're able to stack on a replacement or a repair piece and really match the fracture surface very well because we have all of that data in the digital sphere already. we always talk about, increased efficiency, but when you look at how much time can be saved for complex parts, it becomes very impressive. When you start with a broken piece, such as this one, and you do measurement taking using digital scanning, within 1 day, or even less in a lot of cases, you're able to do what an artist can take 3 or 4 days to sketch out. It's hard to imagine, but we've literally seen artists sit by sculptures day on end, just trying to recreate the 3D data onto a 2D piece of paper, so that they can then use that 2D piece of paper and recreate a physical model in 3D. So all of the effort and the conversions and the changes in perspectives that are required for all of this work creates these delays. Afterwards, the artist needs to spend a lot of time to sculpt, in essence, what is a wax model that can be 3D printed from the scan data or from the digital data very, very quickly. So in, let's say, 2 days, we're able to do what an artist can take a week or 2 to do in his workshop. And then when it comes to installing the work on site, well, it's the same amount of work, right? We're not cutting out the artist's work. We're just taking out the lower value pieces, the piece where he needs to translate something that's existing into something that he will be restoring, but keeping him focused on the high value work that he needs to do to restore the original piece to its former glory. When it comes to the fabrication of molds, BIM technologies help create more sustainable workflows. So in the cases, let's say, of complex farm work for cast concrete, for example, the formwork that is usually used is made of wood and is disposable. So once you're done with the custom formwork, you take it and you throw in the garbage, and you actually have to pay someone to haul your garbage away. In the case of digital manufacturing, you're able to scan a geometry or to create a design entirely in 3D, let's say to print something in plastic or to manufacture a custom piece in plastic, and then use it as a reusable casting mold. Once it has been expended or that you don't need it anymore, plastic can be more easily recycled than plywood, for example. So it has the idea in the future of being more sustainable than its traditional counterparts. Finally, we look at prefabrication of homes using, once again, BIM data. You're able to feed that to a digital manufacturing apparatus to pour concrete, and it allows vendors to produce structures that are very cost efficient. You're looking at complex formwork that would be very, very expensive to do if they were done by hand, being printed for about $20 a square foot. So that becomes a very advantageous way of making what I think is like a wartime bunker. But we can imagine, although most of us would probably not end up living in a 3D printed home made out of concrete, we can see those being very useful for people in war zones or people in impoverished areas where temporary shelters or mass shelters need to be manufactured quickly, where the expertise might not be there for the skilled labor, and where repeatability and making sure that a humane living condition is created is more important than, let's say, aesthetic quality, in a sense. Obviously, all of that excludes windows, roof trim, interior finishes, and quality of life. But in a sense, it's much better to have a roof over your head than to not have a roof over your head. The last application I'd like to talk about is the prefabrication of large structural components. Here you can see a bridge that is standing over Amsterdam today, but that was prefabricated essentially in a warehouse using 3D data and a bunch of robotic welders. It creates a new aesthetic that we haven't seen before because no one would have the patience or the budget to have a welder do this kind of structure by hand. Using robotic manufacturing techniques, we're not stealing jobs from artists. We're doing things they don't want to do anyways, or that we don't have the money to have them do anyways. So I see digital manufacturing complementing the job market and hopefully extending the range of products that we can offer and creating new aesthetics or new settings that weren't believed to be possible, let's say 10, 20, or 50 years ago. So that being said, thank you very much, and I kept my time, so I should be able to take a question or two.